This next session we'll be talking about dual purpose crops and forage brassicas. I would like to introduce our first speaker in this session, who probably needs no introduction, is Bob Freeman. He's a consultant agronomist in northern New South Wales, and he's going to give an overview of the value of dual purpose crops and brassica crops for livestock production and just how they can be fitted into livestock production systems. So thanks a lot, Bob. I'll hand that over to you, and if Lucy, you just take it on to the next slide. Thanks.
Thanks, Warwick, and good morning, everybody. I thought I'd do this talk based on our property, but I believe it's pretty typical what a lot of northern and central New South Wales would see as a fairly reasonable situation. As Warwick mentioned, filling the feed gap through the year is critical, and we regard dual purpose winter crops as vital for filling the winter feed gap. Just a couple of brief details of our property. We're 540 metres above sea level. Our average rainfall is about 650 mil, and we're about 520 metres above sea level. Next slide, please. So this is just, I guess, an illustration of the role of various crops. We don't include lucerne in our business simply because we're mainly acid soils, and that's not just the topsoil but the subsoil. So we depend on tropical grasses for spring, summer and autumn feed. A lot of my talk is going to be on the role of a winter crop and how to ensure it's as reliable as possible, which is pretty difficult and has been especially difficult in this run of drought years. You can see the role of winter legumes there, and they've been fantastic this year, but the previous 3 years not so good, hence the added critical level of interest in the winter crop. Next slide, please. Just showing you our average rainfall. This is pretty typical of northwest New South Wales, but as you go below Peak Hill, it sort of tends to level out a little bit more winter than summer, but for a lot of New South Wales, there's at least as much summer rainfall as winter rain. Next slide, please. Okay, so this is just basically our property. It's not a big farm, it's 700 acres to 83 hectares. 50% of our feed base is tropical grasses with winter legumes. In our case, the winter legumes are mainly subclover, Serradella, bicerula. We still have 30% of our pasture-based native grass with winter legumes. We just call that improved native pasture. 20% is winter fodder crop, and in our case, it's mainly oats. We can talk about species shortly. Our business is mainly buying steers at about 250 kilos and selling them at 500 kilos. Our average stocking rate, we've been around about 260 for the last several months, but our normal rate is 200. But being a trading business, your numbers can be quite flexible, and that's part of drought management. Gross margin per hectare, even in the droughts, we made $150 a hectare, and this year we'll actually end up, we think, around about $600 a hectare. We aim to keep our P level about 20 parts per million, which for Serradella, and it looks like some of that research at Jonathan's looks like pretty fair for tropical grasses. If you're subclover based, you might want that to be 30 parts per million, and sulphur above about 8. We now don't top dress single super annually because we've risen above those critical levels, but we just monitor it year to year. So next slide, please. So here are some of the key winter crop aspects. I think the wider the sowing window, in other words, the earlier we can start, the higher our probability of being able to sow on time. I think this is still an area that requires more research, but we've brought our sowing forward to mid-February onwards, and our probability is around about 95% if we can sow on a small rain event of about 8 or more mils between mid-Feb and the end of March. Good subsoil moisture is important for that. We're spraying our crops out today for conserving moisture over the summer for sowing next autumn or late summer, and we'll spray up to 5 times over the fallow period. I think that's a key factor that a lot of dual purpose businesses don't follow religiously. I know a lot of my friends, for example, still use that rubbish that grows in the fallow for grazing. I just think if you want reliable winter feed, you've got to forsake that. Retain sufficient stubble, that's already been raised today. Winter habit type, I think, is important. PS and N are important. Herbicides, not just Glean and MCPA, but whatever is required to control winter weeds. Nitrogen fertiliser. Just briefly, our average stocking rate's about 2.5 steers per hectare for 130 to 150 days. It costs about $350 a hectare to grow our oats. And the typical gross margin's around about $950 a hectare from the oats. Next slide, please. So how early can we sow? This is a farmer at Coolah who regularly sows early February onwards. And I just think there are a few farmers testing what is conventional wisdom for how early we can sow. And again, we know if you go in too early, there is a risk of being burnt by heat, but I tend to think we can go a lot earlier than what current knowledge suggests. Okay, next slide, please. This is just, again, on our property. We don't ever plough, it's direct drill. Coming out of a native pasture will start now. And every time we get a summer rain, I'll ring the contractor and try and organise him to come about 12 days later. I think it's just so critical to get onto weeds quickly, to conserve moisture, as well as to drive down the weed seed bank that Sue Boschma mentioned and Lester mentioned is so important when you're sowing tropical grasses. Next slide, please. This is just a shot at the philosophy of no need to conserve moisture and just sow your winter forage crop into a native or other type pasture. The problem with the left-hand shot is that the pasture is using water. There's no conserved moisture. It's using it through summer. It's using it in autumn. Generally means you can't successfully sow your dual-purpose crop early, and you end up with very little, if any, winter feed. And I've seen that again this year. Whereas if you conserve moisture, you've sown early, you're almost assured of good winter feed. Just a very important point. I mean, a wheat grower knows this intuitively, but for dual-purpose croppers, we often ignore this basic need for stored subsoil moisture. Next slide, please. This is some of Sean Murphy's research, and Sue Boschma touched on this. Although it's not I think it's just a really good illustration, even though it's a pasture variety trial. If you've got ground cover, as you had with the digit pasture in this case or comparison, you had good production, you had good capture of summer rain. Where you had lucerne or no ground cover, you had very poor capture of water. The same goes for dual-purpose crops. You need to retain the stubble as well as control weeds early. Next slide, please. Okay, so this is a shot in the last drought. We really had 3 drought years consecutively. But if you had stored water from those occasional summer rain events. If you did sow early, it's amazing how much feed we did get from our dual purpose crops, despite it being a drought. Next slide, please. And this is, I think, 2018, although a little bit more rainfall than 2019, was probably a worse year for us. And our stocking rate was half what it normally is on the dual purpose crops, but at least it was still good feed and able to get animals finished to market it at good prices. Next slide, please. Okay, a little bit about varieties. I took this shot in June. Here's the spring variety, which still is, a lot of people, I think, don't pay enough attention as to what sort of variety you should sow. Spring type varieties will grow straight to head, so if you're sowing them early, you'll have them in head in May, late May, June. And the trouble with that is feed quality drops and regrowth is a lot slower. It's certainly great for quick early feed. Next slide, please. And here's another shot of a spring 8 variety sown early and head late May, June. And of course, the recovery of that is often very poor, particularly if soil moisture conditions are low. Next slide, please. I guess this just illustrates what happens. The green plots in this variety trial are varieties of winter habit, and that includes triticale varieties, oat varieties, wheat varieties. The ones that are slow to recover are the spring habit. And all that means is where you've grazed below the growing point or where the head's coming up the stem, that whole tiller dies back and it's got to reshoot again, and that's a delayed action. Next slide, please. Okay. It's great to have all your agronomy right, but if it's all eaten off by kangaroos, it doesn't help. So part of our drought management was to raise our fences on our boundaries where roos come in by about 35 centimetres, and we've done that by welding rods on every 4th line post and putting 2 wires in. Plus we put a barbed wire on the ground, and that's been an enormous gain. Okay, next slide, please. The role of nitrogen, I think we don't necessarily take a lot of nitrogen out of a paddock in a dual purpose crop, but if we grow 6 tonnes of dry matter and say 2 tonnes of grain recovery, we actually are using in that crop about 250 kgs of nitrogen. You can see there an example this year in mid-May of a crop that was top dressed with urea, and the insert is no nitrogen. The amount of feed there is very little compared with probably 4 tonnes per hectare in the nitrogen top dress. So it's just I guess a bread and butter point. Okay, next slide, please. Just another example of where nitrogen's been top dressed and where it hasn't been top dressed. Next slide, please. We'll have more information about brassicas later on. There's no doubt about them, because they germinate and send a taproot straight down. There, in the last, particularly in the drought years, there's been instances, and this is an example of really good feed from the brassica crop versus the cereal is waiting for a follow-up rain for its secondary root system to get going. And I guess we thought we ought to change over to some of our dual purpose crops being brassicas, but the worry we have with only being a cattle business is the problems with deaths. And one of my friends, for example, lost 9 big steers this year, and I just feel this is an area we need to better understand if we're going to use brassicas reliably as a substitute for cereals in our dual purpose program. I think if you're a sheep enterprise, it's much more feasible, but I really feel, particularly if we have showery, cloudy weather, there's a lot of unknown factors here that worry me. Next slide, please. I just mentioned briefly the need for stubble recovery, stubble cover to protect from wind erosion and to capture water. This is just a shot. There's not a lot of stubble there, probably around about 400 kilograms per hectare. And in the background where you see the dust storm, there was none. It was an oat crop grazed right out. And that property probably had 40 major wind events through the drought versus the foreground site that didn't have any. I just think we have to budget not to graze that last bit of stubble out in the dual purpose crop. Next slide, please. I just put this in to show how productive tropical grasses can be. This is a shot cutting digitgrass for hay, 11th of March this past year. And I guess that's part of winter feed supply too, in years where you get really prolific tropical grass like the one we've just had. There's just no way you can utilise all the feed, and it makes excellent quality hay. Next slide, please. I guess it's just another example in a drought year. Good tropical grass if you conserve moisture, if you're sowing on time. We find on our lighter soil, we can actually sow on a rain event as small as 8 millimetres. And I guess if you've got lighter soil, it's not a bad option to keep one or two or some of your paddocks of them available for your dual purpose crops, because you'll get them in on time much more reliably than you will a heavier soil. Next slide, please. Again, another spring shot. I've overemphasised this point. Next slide, please. I'm sorry, this is a repeat. Keep going, please. Yeah, there are a multitude of varieties to choose from. You see the shorter one in the middle there is Urabi oats, a typical winter habit variety which stays very wintry till about the end of July, early August. Then it's quick maturing. So if you're into good grain recovery, that's a good choice. And there's lots of varieties like that in the wheats, triticales and oat line. The green varieties there are the long season spring habits, which are pretty popular in some areas. But as I explained earlier, if you sow them very early, which I think you need to for winter feed, they have the habit of running to head far too early and often having poor recovery. Next slide, please. The computer program How Often is a good way to test the probability of being able to sow in a given window. For example, if we, in this example I've used, if we could sow on 12 mils between the 25th of Feb and 30th of April at Purley-Wall, where we are, we can sow on time 94% of the years. Next slide, please. But if we needed to sow for whatever reason 25 mils, maybe a heavier soil, or maybe we didn't conserve our subsoil moisture as well, and if we needed 25 mils to get a successful establishment, our probability drops quite dramatically to 77%. In other words, we're going to miss out on almost a third of our years not getting reliable winter feed. I think it's a really good program to just illustrate to yourself or your clients how important it is to be able to sow on a minimal rainfall event. That's more or less the end of my talk. Yeah, so happy to take any queries or questions.
Thanks, Bob. We've probably just got time for one question. And one of the questions that's come through is, what was the difference in the management between the comparison of the unprepared oats crop compared to the one that was compared properly?
The one prepared properly had 5 sprays over summer. And in other words, it's conserving moisture. It's not used for summer feed, full stop.
Yeah.
Stubbles retained, or reasonable stubbles retained. The other paddock had no no herbicide spray until just before sowing, very little conserved moisture, inability to germinate till you're well into the late April, early May period, and hence very little. Plus, another factor supported by research is if you let summer herbage grow, your soil nitrogen levels are going to be much lower.
Yeah, definitely. Okay, thanks, Bob. We're just about out of time there. So just like to thank you for that presentation. I think it's a really good overview to set the scene for this session about the need for dual purpose crops and forage brassicas and how we need to work on some of these management issues. I'll hand over now to Peter Hunt, who is going to talk about dual purpose crops for lamb production in the summer rainfall zone. And I mean, my hat's off to Peter over the last few years trying to manage this trial through some really challenging seasons. So I'll hand over to you, Peter.
All right, thanks very much, Warwick, and thanks, Bob, too, for covering up on an introduction to dual purpose crops, a really good one. So through a lot of research, we've found that the introduction of dual purpose crops, as Bob's described them, can increase your farm income by $300 to $1,000 per hectare in southern New South Wales. That's the increase over a grain crop only. So there's some GRDC fact sheets on that if you are interested in finding out more, and also Bob. In the north, it's a bit different. There is more summer rain, as Bob also described. We also have these significant sheep diseases in the summer because we have the wet summers. However, we still have the same winter feed gap, and that's a combination of low temperature but also low soil moisture where the rain is more summer dominant. Can you go to the next slide, please, Lucy? Thanks. So here's a picture of depicting the situation. So we have a summer rainfall, we have fly and worm problems in the summer. We still have a winter feed gap, and can these dual purpose crops fill that winter feed gap is the subject of our research. Next slide, please, Lucy. So this is actually some of Lucy's work, doing some modelling on disease incidence in sheep and what we might be able to do if we alter the time of lambing. So if we can finish those lambs in time, we can actually avoid the worst of the fly strike and worm problems. And we can reduce our fly strike costs by 75%. Click, please, Lucy. For worms, we can reduce dramatically. It's the model's predicting to zero, but I hesitate to say that. And losses of wool production are also reduced. Next click, please. So there's going to be some modelling for other locations in the north of the state and southern Queensland that'll come out as part of our next year of work. So the availability of pasture is another thing we can model, and the availability of feed, including or not including dual purpose crops. So seeing those graphs, the blue and yellow parts are the extra feed you get from dual purpose crops or their stubble. So we can improve the feed supply from June, especially through June, July and August. And you can see from the feed demand curve there, the brown line, that's really, really important if you do move your lambing time earlier in the season to late autumn, because that demand will peak earlier and you'll need that feed. Next click, please. And one more, please. I already said that. So the other thing are all the rules about using dual purpose crops that you must remember. So Bob covered off on many more of those than I was going to mention, but the important one is you do need to lock up those crops from September to give yourself a chance of harvesting grain. So that's the name of the game. It's important if you're going to go that way to get that income through the grain sales. So that's what you have to do. Next click, please. So we've decided to run go back one. We've decided to run a field demonstration trial. It's something that we started in 2018, so that was pre-COVID when parties were still possible, and it was also before the worst of the drought. So some of the things we did jumping into this trial, you may not have done when thinking about life in a real business. Next click, please. and click through till all those little men appear, please. That's it, thank you. So what we're doing is trialling the use of early lambing or late lambing, so late May or late autumn, late August through into September. So they're the two times, and with or without dual purpose crops. One more click, please, Lucy. So we call our little farmlets A through to H, but I've given them names for the benefit of this talk. You can see there's an aerial photo in June last year. The only green things there are the dual purpose crops. So half of the farmlets have dual purpose crops and half don't. Each plot is 1/8 the size of the total farmlet. So in the dual purpose crop system that I'll be talking about, there is 1/4 of the farm sown to dual purpose crops and 3/4 for pasture. And the pasture only, it's all pasture, of course. Next slide, please. So how did this turn out? Well, I can't show everything, there's not time, but I'm showing you land marking percentages because we have those for 2019 and 2020 already, so there's a bit more to show. You can see there that autumn lambing wasn't deleterious for land marking percentage. It's pretty similar to spring. There's slightly lower in the dual purpose crop spring combination that Fred and Brenda have there. Interestingly, in 2020, that improved quite a bit. We're not really sure what that effect is. Next click, please. So it's important to remember what the cycles were. So the spring cycles started with mating in April 2019. Lambing was in August and September. And the lambs were able to be sold in June. Next click, please. And in autumn, we mated in December 2018. As I said at the beginning, we started without knowing what was going to happen. Lambing was in May, and we got those lambs off to sale in March 2020. Next click, please. The second production cycles are underway, and one more click, please. Yes, and I've covered off on this. The lambing outcomes were slightly better in autumn, and one more. And the reason for that are many more multiples in autumn. But you do have to be aware that you get lower birth weights as well, not only because of the multiples, the singles were also lighter in autumn, and that's a known effect, but of unknown cause. Next. Yes, we've covered off on that. Thank you. Bye. Thank you. Next slide. So this is the growth curve of the lambs from all the groups. Obviously, there's no dates on the bottom because they don't actually sit on top of each other. You can see we got very similar results across the board. The one click, please. The farmlets that had dual purpose crops performed better. On average, they had 6.7 kilos heavier lambs at sale. Next click, please. So for comparison, if you compare single born to twin born lambs in the same groups, the singles were heavier by 5.6. So you can see the effect of dual purpose crop was similar to the effect of single versus twins. Autumn versus spring, much less of an effect. Autumn lambs were 2 kilos heavier, and that's about the same as the difference between male and female lambs. Next click, please. And the carcass weights followed a similar pattern. Next. The spring lambs, as far as the disease story goes, they had 2 drenches. We did use a fly prevention treatment, and one was struck, which comes through as a percentage of about 1%. So in a drought year, I guess that's not too bad. Next one, please. Our autumn lambs, on the other hand, had no drenches at all. We didn't use any fly prevention products, and none were struck. So it meets the expectations. Next slide, please. I'll talk briefly about the cropping enterprise. So this is the canola that we managed to sow in April, late March actually, in 2019. And this is what it looked like in November after some grazing events. It recovered by then, but not by much. Next click, please. You can see that's how it should have looked. That's from this year, last week, I think. And that's there's a big difference. So obviously we didn't get an income from cropping out of this this year, the 2019 year. Next click, please. Okay, so how did these different things stack up from a financial point of view? Click 4 times, please, Lucy, to get all the numbers up. Thank you. So you can see there that the expenses are massive, and that's mostly to do with feeding animals through the drought. And really, it's a message to us all about destocking in droughts. Next click, please. So you can see that autumn lambing with dual-purpose crops provided gave us the best income. That includes both wool and lamb, that income. Next click, please. But the best, or the least bad outcome for gross margin was actually the spring lambing with pasture only. And that's predominantly to do with lower expenses because they didn't plant crops. And go to the next slide, please, Lucy. The rest of that story is about the fact that those two production windows don't completely overlap with each other for obvious reasons. And the last quarter of the spring lambing, we didn't need to hand feed. The drought broke for us here on this place, so we saved a lot on grain. So is it a fair comparison? Well, I don't know. It's impossible to do the comparison without these sorts of things happening. That's why we're doing it over 3 years, and hopefully we can have some follow-up webinars and let you know how things are happening in the future. Next click, please. So thanks for watching, and thanks to all the team listed there who provided help to get this project done. We're basically running 10 farms simultaneously to do this work because we have to have spare ewes to keep the stocking rate constant. So there's another 2 farms, and thanks also to a whole stack of consultants and suppliers and contractors too who've helped us along the way.
Righto, thanks, Peter. That was good overview of that research and the challenging system used to do systems research where you're trying to maintain animals and a consistent experimental design is a real challenge. So as you've shown, I'd just like to see whether anyone has any questions out there. So just while we're waiting to see if any come through, Peter, what are your thoughts for this coming year now that you've got a bit of an idea of the production that's likely to come from this season? Which treatment do you think is going to perform better in a better season?
Well, we're already very hopeful of getting a commercial grain crop, both canola and wheat. We grow both. So that'll make a big difference. Our expenditure on hand feeding is much less, although it will include for this year some of the hand feeding over the summer for the autumn ewes, and for the ewes, yeah. The lambs are growing faster, I can say that. We struggled to finish them all by March, the autumn lambs by March last year. This year, I'm pretty confident we'll get them off in January. We might even get them off in December. But I'm sure everyone listening knows how hard it is to schedule things in abattoirs around Christmas. So it's not only about the growth rate of the lambs, that one. So yeah, I think things are much better. As to which group are going to perform better, I'm not sure. The fastest growing lambs are still in a dual purpose crop group for the autumn guys. Haven't really got a feeling for the spring ones yet. They're not long weaned. So yeah, we'll have to watch this space and see what happens.
Righto, thank you. We got any other questions out there? Okay, so we haven't haven't got any more questions for Peter, we might hand over to Lucy for her presentation on forage brassica and mixed farming systems, and I think she'll be able to pick up on a lot of the variety and production stuff, but also some of the issues that Bob raised around some of the palatability and animal health side as well. Okay, thanks a lot, Lucy.
Excellent. Thanks very much for that, Warwick. And also thanks to Bob for a bit of an introduction into these forage brassicas. So this is a project which is looking at forage brassica use in mixed farming systems. A lot of you would be aware that forage brassicas are typically used in higher rainfall regions, such as the dairy, and also in some meat sheep systems as well, including New Zealand. So today I'll just be talking about the different evaluation sites where we have looked at these across different production environments, and also a little bit of work from Rebecca Stutz as well, who has done a lot of the livestock production work as well as supplementation work as well. So just a little bit of an overview of the potential value of forage brassicas in those northern crop livestock systems. So they are typically, we're looking at them to be sown as an autumn crop to fill that winter feed gap, and that winter feed gap is a really common issue across much of that region. One of the main benefits of the forage brassicas is that they are a broad range of genotypes, and that means that they have diverse applications. They can be used either as a multi-graze crop or as a single graze crop when you're looking at creating a feed wedge, when other feed on farm may not be of high quality and also quantity. And particularly in those northern regions as well, we're looking at their potential as a break crop, and that's to manage those soil-borne diseases, which are very common in those grain crops throughout the region. They also have a really high nutritive value, and they're able to maintain that high nutritive value over an extended period, and that's compared to grasses and also cereals. So they're not only able to provide feed over that winter period, but also feed of high quality for much longer. Bit of preliminary work was done by Lindsay Bell and some others in 2011 and 2013, and that's really indicated their high potential in this region. So these were done in southeast Queensland and also northern New South Wales. And from that preliminary work, Lindsay identified that there was really high production potential of forage brassicas. They were producing more than 5 tonnes of dry matter per hectare, and that was growing just under 50 kilograms of dry matter per hectare per day. So pretty high potential there for feed base. And compared to forage cereals and also forage legume comparisons, they were either equal to or they were producing much more than those standard conventional types. They also identified that some genotypes were resistant to the nematode P. thornii, which a lot of you would know is a disease in a lot of those cereal crops. So our current research project is looking at new forage brassica options for this drier environment within the mixed farming zone. And today I'll be focusing mostly on the relative productivity of those new and existing genotypes that are commercially available. But also part of this project, we're looking at doing some modelling to predict the productivity across different production environments using those the data collected from those evaluation sites. And we'll also be looking at how forage brassica integration can improve the productivity on farm, and that's in terms of the feed base. Rebecca Stutz has been doing the work on the project focusing on livestock performance when grazing brassicas. And again, I'll be focusing on those in red today, but we're really just trying to develop a better understanding of the dynamics of feed intake and also the conversion during the adaptation period. Bob mentioned that there are some palatability issues, and that's something that we're trying to work out through this project, and also some supplementation requirements and responses. So some of you may be aware that when grazing winter wheat, there are some supplements that are recommended to try and increase animal performance when grazing those cereals. And we're also looking at managing the high nitrate risks as well when grazing brassica crops. As many of you are probably also aware, they can be quite risky to animals if they're not managed appropriately. So just a bit of an overview of where our current research sites are located. We are right across the mixed farming zone as far west as WA and as far north as the Toowoomba region. And we've also got some collaborative research sites as well that are set up, one near Adelaide at Lameroo, very challenging environment, and some with Matt with AMPS research there around the Gunnedah region as well. We also have our grazing sites which have been located down in southern New South Wales around Canberra and Greenthorpe, if any of you are familiar with the Greenthorpe region. So as you can see, these production environments don't only differ geographically, but also in terms of their soil types. So we're just wanting to see how they'll perform right across that zone. We also have managed to set up 16 on-farm demonstration sites this year, and again, they're located right across the region. We've got one that's located at Boggabri there with Aidan Rodstrom, and I'm also managing the ones in southeast Queensland, and we'll really just be focusing on a lot of the work in that northern region today. So just a quick overview of what our major findings are before I go into the major details. But we've found that several genotypes compare favourably to forage oats and other cereal crops. They produce similar or lower edible biomass compared to forage oats, but when you start looking at that in terms of the actual things that contribute to animal production, such as metabolisable energy and crude protein, forage brassicas sit well above that forage oats, especially later in the grazing season. We've really found that within the early grazing window, our bulb turnips, they're really getting out of the ground quickly. A lot of leaf is produced as well as that bulb, which is accessible by animals, which we also measure in our biomass. And then we've got our forage rapes and our dual purpose canola, and then the others thereafter. But late in the grazing season, this changes a little bit. We're starting to see some are a lot more tolerant to those drier conditions as the soil moisture starts to dry up, especially in the conditions we've had in the last 2 years. So the Rhapno brassica, followed by forage radish, and then the forage rapes are definitely a lot more adaptable, and I guess a lot more, they have a lot better fit in that later grazing window. So when we look at forage biomass and nutritive yield, so this is the late grazing window, and you can see there that forage oats, which is right across on the left-hand side, is sitting well above the rank as a % of site average. So this is across all of our sites. All of them are ranked based on site average, and then that is the average of this. So it's just a good way that we can look at overall performance. So you can see that the forage oats are sitting well above there compared to the forage brassicas. There's some forage brassicas, particularly the forage rapes and also the Rhapno, that are sitting above that average line. But then when you start looking at the yields of metabolizable energy and crude protein, there really starts to be not a lot of difference in terms of that product that's really important for animal production, and that is the energy and protein. So you can see there, just indicated by the blue box, that the dual purpose canola, the Pallatin Rhapno, and also those forage rapes are performing really well within this grazing window. So within our northern sites, we identify that forage rapes, they're definitely a contender, followed by our Rhapno, our Pallatin, and also the rival bulb turnip as well. But it's really important when you're considering the integration into your own farm that some are a multi-graze crop. You can get anywhere between 2 to 6 grazes off a Rhapno or a forage rape, where your bulb turnip it's really typically considered a single graze crop, because once the animal does damage to that bulb, the plant really will just be terminated, so it won't continue growing. It's more of an issue if you're grazing them with cattle. Sheep are less likely to really get stuck into that bulb, and will focus a lot more on that leaf. So some major findings from Rebecca's work on livestock performance. We found that supplementation of trace minerals such as copper, selenium, and also iodine had no effect on live weight gain in lambs grazing brassicas. And Rebecca looked at this in 2 summer trials. So she dosed half the lambs with a copper, selenium, and iodine drench, and the other half were just the control, and they weren't drenched with anything. She also found that some brassicas are more highly preferred by livestock, and she can't relate that to the quality attributes like metabolizable energy, crude protein, the fiber contents, and also the digestibility. And it's also not related to the biomass availability either. So there's there's often plenty of biomass available, but the animals just aren't eating it. So when you're looking at the forage characteristics of forage brassicas compared to dual-purpose canola and forage oats, you can see they're indicated by the green bars. That's the early window, and the yellow is the late. And you can see that forage brassicas and dual-purpose canola really hold on to that nutritive value a lot more than the forage oats. And even so, compared to even within each window, you know, the forage oats sits a lot lower than the forage brassicas in early and late windows, as well as declining quite significantly, especially with that crude protein. And that's pretty typical as you start to produce a lot more stem. So in terms of land performance and the number of grazing days that can be achieved with grazing forage brassicas, so this was some of Rebecca's work again. She did a summer trial that was looking at 4 different brassica crops. So she had a forage rape, a canola, the rafno, and also a kale. And she found from this study that the forage rape had the shortest acclimatization period. So animals were actually gaining weight on that crop a lot quicker than on the others. And for kale, it was suboptimal. So their acclimatization period was a lot lower. But however, when you compare them to the amount of biomass that was available, you can see that the rafno brassica, it had 6.6 tonnes of biomass available at the start of grazing. And at the end, they still had 4 tonnes. They were a little bit aversive to it at the start. But when you convert that to DSC days per hectare, the rafno brassica was also well above those other brassica types. And it's purely related to the amount of biomass that it's producing over that summer period, period where it is very dry, and it was very dry in Rebecca's trials. And you can see, as I mentioned in the previous slide, this wasn't related to the metabolizable energy or the crude protein in terms of the acclimatization. The animals, there's something else going on we're not quite sure of yet that makes these animals a little bit aversive to certain species. And that's what I'm talking about in this slide, where we look at the variation of grazing preference between different genotypes. So this was a winter grazing study. Rebecca grazed with merino lambs. They were all naive to brassicas, so they hadn't been previously exposed even to dual-purpose canola in their life. And she grazed these as replicate blocks. So what that means is that all of the different brassica species were all put into a single block and replicated 4 times. And the animals were just allowed to move around to whichever genotype they wanted to try. And she has measured the preference as a difference between the amount of biomass that was available pre-grazing and then the amount that was available after. And you can see really the main things to look at are the green bars. That's our change in biomass. And you can see from here the bulb turnips, so our green globe and our rival, and also our hunter, which is a leaf turnip, they were least preferred. They actually accumulated biomass over the grazing period, where things like the Palatine and also the regal kale, they were a lot higher preferred than the other forage brassicas that were available. So this kind of contradicts a little bit what Rebecca was finding in her summer trials. So again, it was bringing up a lot of questions about, you know, is there an environmental impact? Are there differences between animals? Are there some compounds that are within some genotypes that aren't in others? And that's raised this question: are there plant secondary metabolites which are potentially playing a role? And I'm not sure if many of you have ever heard, but there are some known primary plant secondary metabolites in brassicas, mostly glucosinolates, also SM-CoS and nitrates, and they can cause aversion in animals. So some animals will not eat it because it can cause upset stomach effects, or it has a bit of taste, and it often can take animals quite a bit of time until they start to really get into that crop. And that all comes back to grazing management as well. But what Rebecca is hoping to look at with this next phase in her work is, are there some genotypes that are just naturally higher in some of those plant secondary compounds? And this is both going to help with breeding of these different plants, so that we can try and produce a lot of forage brassicas that are highly palatable to livestock systems, because clearly they do have a very a very high potential with that high metabolizable energy and digestibility, and also crude protein. And we want to see livestock doing really well on these crops. So this is one of our on-farm demonstrations, which is based in the northern region in Millmerran, southeast Queensland. So this farmer is growing Titan forage rape, and he's grazing with some Dorper sheep. These sheep actually like to stay within the fence, which is good. They're pretty happy on this brassica crop. So David sowed on the 19th of May, and it was dry sown. These guys have had a really tough couple of years, so he just, you know, bit the bullet and decided to dry sow and was hoping that it would pay off, and it did. He put in the 25 hectares. He did get some rain shortly after sowing, and it managed to establish, which was great news for us. But since then, he's only had 40 millimeters of rainfall. So, you know, it was pretty tough, but he has managed to get some really great results off it. So looking at the start grazing biomass, which was taken on the 20th of August, we had 1,000 kilograms of dry matter at that point, and we just decided to get stuck into it and graze it before it turned. Dave got a total grazing days of 363 days per hectare. He was averaging 283 grams per head per day. He actually had some ram lambs that gained 450 grams per head per day, and the average for the top end of those ram lambs was 300 grams. So he was pretty stoked with those results. When we then convert that into total production in terms of live weight per hectare, Dave was getting 102 kilograms per hectare, and we estimated the value of that to be $360 per hectare, and that's calculating total production by $3.50 kilograms of live weight. Another thing that David has also been testing on his farm is looking at forage brassicas in a mixed sward. So you can see in that bottom photo on the left-hand side, he's actually sown a leaf turnip forage brassica with oats, vetch and clover, and he's grazing that currently. He's just taken them off, but I'm yet to get the results on that. But he was very impressed actually how well that leafy turnip had competed with the oats and the other species in the mix. And I had a very friendly potty lamb that came up for a photo. So this is also another benefit to forage brassicas is that they're highly responsive to rainfall. And you can see here the photo taken on the 6th of October. This is right at the end of that grazing cycle, and it was looking pretty crispy. It was very dry underfoot. And David sent me a photo just the other day after 32 mils of rain, which they've just got in the recent storms. And you can see there that it is really picked up, and he's looking to graze that again in the next couple of weeks. And I guess this is a really important thing because David at this point in time now really has only dry residues available on his farm other than this forage rape, and his oats also have really, they're done pretty much for the season. So he's looking at this now as an option to feed over the late spring and summer period, and he's pretty happy with that, and he's just hoping for more rain. Hopefully it can continue. So I guess the question is now, are you interested in using forage brassicas in your system? But before we do that, we need to go back to the basics, and I'm sure you've got plenty of questions about grazing management and also agronomic management of these crops. Some of you probably haven't had exposure to them in the past. So one thing to consider is the genotype choice. So it's really dependent on the forage brassica type. So, you know, whether you're looking at a leaf type like your forage rapes, your rhapnobrassica, or also your leafy hybrids, compared to your bulb brassicas. So that's just like a bulb turnip and a swede. And that's, you know, whether you need to graze them in multiple cycles, or as I mentioned earlier, if you want to only graze them singularly and just keep them as a feed bank for when all of your other on-farm feed supply is declining in quality and quantity. So I've just done a little table here just to show the differences between the multi-graze genotypes and also the single graze genotypes, and how many days to maturity you can expect. For the forage rape, they have a lot more days until they reach that grazing maturity compared to the rhapnobrassica and also your leafy turnips. One of the main benefits with the forage rape and the rhapnobrassicas is that they really are a long-term feed supply. So provided moisture is available, you can have feed from these crops for up to 12 months. And there has been work done on dual-purpose canola, and they've found that these the dual-purpose canola is actually extending its roots to as far as 4 metres into the soil. So we're expecting that the forage rapes and the Rhamnobrassicas would be getting down that far as well and being able to access that deep moisture store. With your leafy turnip, they're really a medium-term kind of source. You can get 2 to 4 grazers from them, but it's really moisture dependent. And from our trials, we're really finding that they do struggle in those dry conditions. They take off really quickly with that warm weather, and if there is a bit of moisture there early on, but yeah, they turn pretty quickly, which is a shame. The other thing, forage radish, it's more like short, medium term, less than 6 months probably expected for grazing. We have found through our studies that they actually have gone to seed, and yeah, that's also a limitation to them, I guess, with their grazing capacity. But you know, you can manage some of that reproduction through grazing management. And then you've got your single graze genotypes, which are definitely a lot higher maturity times, especially that Swede. And they're a short-term grazing, as I mentioned. They're just a single graze crop. But one of the main things is that generally forage brassicas do have a large vernalisation, the forage rape and Rhamnobrassica in particular, and that just means that you know they've got that potential for a winter and spring summer grazing, and that's for an autumn sown crop. So in terms of agronomic management, we have so autumn sowing seems to be best, aiming for that March-April. The optimal sowing rates are yet to be evaluated, and we're also looking at sowing depths at less than 35 millimetres. We also have an on-farm demonstration site that's currently looking at spring sowing, and that's located in Boggabri in northern New South Wales. You really need to feed these crops. They do like N, and you can see there that you know the biomass yield potential compared to your nitrogen fertiliser requirements, and you know you're really maximising that yield potential if you're feeding it well. One thing is that forage brassicas are naturally high in sulphur, so looking at selecting those lower sulphur containing fertilisers just to mitigate any animal health issues. They are suitable to a wide range of soil types. Their pests and diseases are generally very similar to canola. And when you're looking at weed management, you really need to be mindful of residual herbicides, especially when growing in rotation with cereals. And currently there aren't a huge number of registered herbicides, and there's no Clearfield or TT cultivars available of forage brassicas. There are in New Zealand, and we're hoping that we'll have access to some of those in the market in the near future. As I mentioned, nitrate can be an issue, so don't fertilise before grazing, and leave them out for a minimum of 3 weeks. And really, if you can get an effective rainfall within that time too, that's optimal. But just gradually introduce your livestock to these crops, and you can do that either by gradually introducing them on a day, for 5 days, gradually introducing them for a few hours a day, and then putting them in for unrestricted access, or you can provide, you can put them in the paddock and just provide them a high quality roughage. And I do stress a high quality roughage is very important. No straw, because you really want the animals to be able to eat that hay and dilute any of that effect if they're going to have any issues. And that's all. Thank you to everyone who has participated in the project, including our technical staff, Brett, Tony and Andrew. Yeah, there's been a big project, and hopefully you guys have a lot of questions. So thanks very much.
Thanks, Lucy. That was a really nice presentation there about the work you've been doing, and I think probably hits on a lot of questions that producers have got who've been trialling these things. Also, I'd like to mention we've got Lindsay Bell on the line, who's also part of this project, who can help to answer some of the questions if they come up. Okay, we've got one here. In Central West New South Wales, we've had some sheep get photosensitization when grazing dual-purpose canola and forage brassicas. I know this can happen when the plant is grazed too early, but what in the plant actually causes this? Thanks.
Thanks for that, Anon. So we are doing a bit of work on this at the moment with Rebecca, and we're trying to identify exactly what the compounds are that's causing it. My guess would be glucosinolates, and also there's those SMCOs. You know, you find this, you know, an issue with primary photosensitization a lot, even in the dry conditions and coming out of drought as well. I don't know if this is like more a recent issue, but you know, I've even heard animals getting photosensitization on lucerne down south recently, and that's from aphids. So it's hard to identify exactly what the compounds are. I guess the main thing is that if you do identify it on your farm, that your animals are actually getting photosensitization, it's really key to get them off the crop as soon as you can. And get them into some shade just to avoid any further adverse effects. But really, this is, yeah, it's really more like further stuff will come out of this project, and hopefully with those plant secondary compound analyses that Rebecca's doing, we'll be able to identify a few more of those issues.